Two South African digital media companies were commissioned by MTE Studios, an exhibition maker based in Cape Town and Dubai, to develop 21 digital unique interactive media installations for a newly built science and technology museum in Saudi Arabia. Their interactive AV productions display various aspects of the technical and scientific advances of the Islamic world from 700 BC to 1700 BC in the fields of maths, medicine, astronomy, art and architecture, chemistry, botany, besides others. During the 6-month design and production time, the companies worked closely with MTE Studios, who were responsible for research and copywriting, to conceptualize each application and together making sure the overall design of each exhibit was appropriate for the target market and subject matter, as well as taking into account cultural differences when displaying certain imagery, such as the human body. The flagship exhibit of the museum is a 5-meter-long rear-projected multi-touch table, allowing multiple users to interact simultaneously with the timeline of Islamic contributions to science and technology. Spanning a period of 1,000 years, the timeline multi-touch table includes more than 300 historic events relating to important discoveries and achievements of the time. When first approaching the installation, visitors of the museum get an immediate overview of key events, which are represented as markers and title text on the sequential timeline. In order to accommodate the massive amount of content in a seamless presentation across the table, the interface lets users open and close 20-year time windows by selecting the periods from either the Arabic or Gregorian calendar displayed on both sides of the table. By touching the table's glass surface at the point of interest, a 20-year time window opens up showing the events that occurred during that time. Next, visitors swipe their hand or finger up and down to revolve event icons around the central timeline, bringing desired content to the fore. When a particular event is selected, a window opens up showing images, animation and text related to that event. Language can be easily toggled between English and Arabic simply by swiping your hand or finger across the content left to right or vice versa. Events of major importance trigger Uber animations that span the entire table. This may mark the extraordinary travels of Ibn Battuta from Tangiers to China, or coins raining onto the table representing the first use of gold coins in the Arabic world. To create a multi-touch table of this scale, the glass surface had to be divided into 3 sections, although the graphical interface design creates the impression of a seamless surface across the entire table. Visitors explore the content of the timeline by walking around the table, interacting with both sides, which effectively means the timeline is 10 meters long. The interface works with intuitive gestures, such as dragging and swiping. The application itself was developed in Adobe Flash and uses a live socket connection to synchronize the 3 sections of the table, each of which is driven by a separate quad-core PC. To achieve multi-user functionality, the development team made use of innovative camera tracking technology which identifies fingers and hands of visitors touching the surface. In addition to developing the software, we also designed and built the hardware from the bottom up and shipped the entire table to Saudi Arabia in massive wooden crates. All in all, the Timeline Touch table uses 3 quad-core PCs, 6 tracking cameras and 6 data projectors mounted under the table's surface, along with power surge regulators and an effective cooling system. The Geometric Art Multi-Touch table invites users to design their own arabesque patterns using predefined elements. The application offers the option to recreate patterns which are displayed in the background of the table. Alternatively, users can create their own patterns using a repository of predefined elements. The table measures 1 meter square and uses 2 data projectors. Another 1 meter square projection table uses sophisticated pattern recognition technology, allowing users to navigate content information by placing physical cards onto the table's glass surface. The circular cards, divided into English and Arabic, are held in 4 containers, 1 in each corner of the table. Each card represents a specific topic in the field of mathematics. Once a card has been placed on the table, a circular menu is projected around the card. Next, visitors rotate the cards to select the desired subcategory, which is presented with text and images. The interactive Islamic world map shows the extent of the Muslim world during its heyday in the 12th century. Visitors page through the wooden pages of a large physical book, taking them through the expansion periods of the Muslim world. Simultaneously, animated maps illustrating the events are being displayed on a 56-inch plasma screen above the book. The interface was realized using magnetic sensors in the book connected to a serial connection on the PC. This "Why did Islamic science flourish?" display engages a pulley system, allowing the user to drag a large plasma screen from left to right. When changing the position of the screen, the user scrolls through content chapters which present 12 reasons why science flourished in the Islamic world between the 9th and 12th centuries. This top-down projection onto a 2 meter by 1 meter vacuum-formed topographical relief surface shows an animation explaining how early Islamic settlements were formed and grew into large cities. Additionally, the scope of work included a series of custom-designed touchscreen applications covering a wide range of topics in the fields of science and technology. The Islamic Inventions touchscreen gives access to a large repository of inventions and discoveries by Islamic scholars of different eras. The Golden Ratio touchscreen explores the role of Fibonacci, who was the first to introduce Arabic numerals to the West. It also highlights the connection between the Fibonacci numbers and the Golden Ratio, shows examples of the Golden Ratio in nature, art and architecture, and let users experiment with numbers to create their own geometries based on the Golden Ratio. The Human Anatomy Touch Wall is a portrait-mounted 56-inch touchscreen whereby a user drags an on-screen magnifying glass over an illustrated human body, revealing early Islamic knowledge of human anatomy. The Muslim Polymaths touchscreen honors the many Muslim scholars who have contributed to science which is still of significance today. The application shows a 3D recreation of the House of Wisdom, a scholarly institution founded in Baghdad in the 9th century. Visitors are invited to meander through a number of rooms in the building and meet representations of 40 scholars who introduce themselves to the user with voiceover.
I'm Al-Zarqali, an astronomer. I made many observations on the positions and movements of celestial bodies and invented new astronomy instruments.
Muslim scholars were knowledgeable in the science of herbal medicine. This touchscreen application emphasizes the role of Muslim scholars in the field and features a lexicon of medicinal plants and their uses. Islamic architecture is world-renowned. 3 large touchscreens deal with architectural elements, world-renowned sites, and arabesque patterns in architecture. The touchscreens are mounted next to each other with complementing screen design in order to create the appearance of a seamless presentation. The first pharmacist's touchscreen presents a number of scholars who were experts in pharmaceutical science. The skillfully illustrated interface makes use of the parallax principle, which creates the illusion of a 3D space. Users navigate content by scrolling horizontally through the parallax illustration and touching items and people of interest. The Virtual Books touchscreen presents the original illustrations and text of Al-Jazari's seminal Book of Knowledge of Ingenious Devices. Cryptography was an important application for skilled Muslim mathematicians. The touchscreen application teaches users about the origins of encryption and lets them experiment with the basic principles of cryptography. Roots of Technology is a timeline application displaying several hundred entries on Islamic contributions to science and technology. It reveals how inventions and discoveries originating in the Islamic world were often falsely attributed to Western scholars centuries later. The Western world adopted Arabic numerals as the standard. But why was it the Arabic numeral system that proved to be better than the Roman and Babylonian systems? The numeral system's touchscreen lets users experiment and calculate with the 3 different number systems to find out for themselves. The Ibn Battuta game touchscreen challenges users to travel in the footsteps of Ibn Battuta through the world of the 14th century. The goal is to pick up 5 treasures on the way. In order to move, players need to answer several multiple choice questions correctly. But watch out, the Black Death is looming. At the exit of the exhibition, the quiz touchscreen allows visitors to see if they've memorized the most important facts. The quiz draws from an expandable database of over 100 questions and displays them randomly. After 10 questions, it compares the user's score to the average score of others in their age group and gender. The 2 Cape Town companies faced a number of challenges in the course of the project, the main being a very tight deadline of 6 months for design and production of all 21 exhibits. Key technologies used in the project had to be acquired and brought to perfection rapidly, such as building the multi-touch table hardware. Last but not least, the display of content in both English and Arabic presented an interesting design challenge, considering Arabic is read from right to left and back to front. The development team eventually created a genuine custom Arabic text display function in Adobe Flash, as simply arranging the text right did not render the Arabic correctly, as we discovered some way into the project.